Oh, hey, welcome back to another episode of A View from Earth, the official podcast of the Fisk Planetarium at CU Boulder. As always, my name is Colin Sinclair. I'm an undergrad at CU. I study astrophysics and computer science, and I am joined by my co-host, Tara Tomlinson. Hey, Tara.
Hey, Colin. Hi, I'm Tara. As always, I'm a CU alum and a planetary scientist, outreach coordinator and presenter at Fisk, and co-hosting this podcast.
And we also have our producer, John Schiller, here. Hey, John.
Hello.
And that's it from John. So today, this is our final episode of season 3. We kind of, it feels like we just got here so quickly. And today we're talking to Dr. Jack Burns on space policy. And I think this is going to be I think you're really going to like this one. There's a lot of cool stuff that we've talked about. And we were actually discussing just right after the interview, we were talking about how wide, like how far reaching this conversation went. I feel like we really touched on just subjects all over the place.
Yeah, totally. And, I've always been one of those people that I don't want to do policy. I don't want to ever be in politics or anything like that.
Yeah.
But I found this absolutely fascinating just to learn about all of the different, from science, we really only see the one side, but I guess somebody like Dr. Burns, who's kind of the mediator between science and government, he's got some really cool insights on things. I feel like I learned a lot.
Yeah, well, and I think he's got a really unique vantage point being a researching scientist and a policymaker, right? And right. Sitting on all of these committees and boards, regarding space policy. And one of the things we talked about is that very, very rarely are U.S. legislators also scientists, right? That is pretty uncommon. And
almost never, I would say.
Right. Yeah. Well, yeah. If you're doing science, if you are a PhD scientist, that's probably your career. So I think it's important to have people that really know both, right? Because there's things about policy, obviously, that scientists don't understand, and vice versa. So right. People like Jack Burns take care of that, at least start to.
And I think it goes both ways too. Most of us scientists don't really know maybe enough about how right. policy, especially for people who are 100% reliant on the government to fund our research and give us money to do our work, but yet we don't really have a great idea of what happens after we push that proposal off into the ether, or here we publish this white paper and it's gone now. Right. And I don't know what happens after that.
Well, something that I was curious about that I was going to ask about, and then we kind of moved on, was, Dr. Burns told us how he'll often, talk to legislators and, about some proposal or some space-related policy, and how that often involves education, right? Because the policymakers don't know, right? They're not scientists. They don't, primarily work in space. And so sometimes you have to fill them in. And I was curious, I wonder if that's something that they are open to, if they're like, yes, fill me in, and teach me, or are they kind of like, I just want to get to the business, right? I don't, is it a challenge to get these people to listen to what you have to say, if they view it as unimportant or a waste of time?
I imagine it'd be like that with pretty much any field, though, if you're trying to sell somebody on, new medical technology, and they're like, I guess that's probably a bad example because everybody needs medical technology. Right. Not everybody really needs space exploration so much. But I imagine that happens with a lot of people, and it's all very interest based and lobbying groups and blah, blah, blah.
Right. Well, a friend of mine and I were talking about the same question that I asked Jack Burns about, how come we're giving so much money, so much, still a lot of money to space exploration and research when, there are other things like, what about like medical research that we could give that money to, or, any sort of any number of social programs. And my response to that question, in addition to what Jack said, is there's a lot of stuff that's come from space science that now is used widely, right? But the space was this, the space research was kind of the step to get there, right? I mean, think about like computers and cell phones and all of the technology that we use today. So much of that was informed by the necessity to communicate with someone really far away instantaneously, right? That probably wouldn't have turned up, at least not when it did, without, in the absence of space exploration. So that's another, I think, defense of funding space research is that it's not only for space, right? Everything that comes out of it, everyone gets to use.
Yeah, exactly. I've heard that argument too. I think Dr. Bagenal was one that pushed that to me one time, is that, yeah, there's so much space technology ends up benefiting everybody. I mean, right. Yeah, cell phones, stuff like that. Or I've also heard of I think they called it the Star Trek effect, where it's like using space science fiction gives us, I don't know, some sort of the imagination, I guess, to think of things like onboard computers and GPS and faster than light travel and stuff like that, things to work towards that then go on to benefit humanity as a whole.
Right. Yeah, that's exactly one of the points that came up in my conversation was, well, why don't we just give money to people, who are to come up with ideas to help, things happening on the ground. And that's exactly it, is that maybe those ideas are obscured until you look at, working with something like space exploration, and then things that pop up you might not have anticipated. And those are, really the reason for these crazy ideas.
Yeah. They don't realize that that's exactly what they're doing. They're just doing it in a roundabout sort of
way.
Right.
Yeah,
You're giving me money to come up with cool stuff for you. It's just going to take me a little longer, and I got to do those weird tests in between.
Right.
Of sending something to another planet.
Yeah. But now it works, right? Now you're getting the best version, or at least the best first version that there could be. So.
Right. Yeah, it's the best prototype we've got.
Yeah.
But yeah, that's definitely an aspect to it, I think. And that's another thing. I did a report on it in a public speaking class that I had to take at community college of why we should continue to fund NASA, because it was at the time our favorite dude from Texas, Ted Cruz, was trying to cut our funding by like a ridiculous amount.
Sure.
And so I had to do a whole speech on here's what your NASA money is actually paying for. And it's really, I mean, this was like 7 years ago. But at the time when I looked it up, it was really like each person in the United States is giving NASA something like 2.3 cents a year.
Wow.
So it's like, wow. And you're complaining? Give me 2 cents and let me send something to Jupiter.
Yeah. Or, right. You can get, you'll get pictures from it that are worth much
you'll
more
get your
than
investment back.
Cents. Yeah.
It might be a while, but you'll get your 2 cents worth. I swear.
Right. Cool. Well, hey, I think that this might be a good time to jump into our interview and let Jack Burns do some of the talking.
Sounds good. So today we are talking with Dr. Jack Burns, who is a professor and an active NSF and NASA-funded researcher in the Department of Astrophysical and Planetary Science, APS, at CU. His teaching and research focuses on extragalactic astronomy and cosmology, supercomputer numerical simulations, astrophysics from the moon, and what we're talking about today, public policy issues in higher education and science. Currently, Dr. Burns serves as the chair on the NASA Advisory Council Science Committee and also chairs the American Astronomical Society's Committee on Science and Public Policy. So thank you so much for joining us today, Dr. Burns.
Glad to be with you, Tara.
We are super excited to chat with you. So one of the first things we wanted to ask you is this idea of space policy. Has this always been something that interests you, or is this something that came with your experience of doing science?
Yeah, it really came with doing science over the years. Spending a lot of time in Washington, advocating for missions, advocating as part of the American Astronomical Society for funding for astronomy and astrophysics, getting to know the movers and shakers on Capitol Hill, a number of administrators of NASA over the years. So you sort of build up a little bit of that expertise, actually a lot of that expertise over a period of decades, seeing how Washington works, seeing how to get things done. And then when I I joined the faculty, rejoined the faculty at CU after serving as a vice president for academic affairs and research. I started teaching a class on space policy almost 15 years ago now. So, and do that pretty regularly. So that too, you know, teaching always further develops some expertise.
Do you think that's this your expertise now in space policy? Does that help you now when because you're still actively doing research and proposing missions? Do you think this gives you a little bit of a leg up when you're putting out these proposals and making these calls?
It does, because you know, I know the movers and shakers. So I served 4 years ago on the transition team for the then incoming administration for NASA. So our job was really, and I was the only scientist on the team. So our job was really to look ahead and what is NASA's program going to be. So that really is jumping right in the middle of the policy. So what is the right balance between science and human exploration? What is the right balance between the sciences and the directorates? And so that was a very interesting experience. And then of course also just watching an entire, you know, administration begin to take shape was a novel experience for me. So, you know, actually doing this kind of thing and being involved at the highest levels is you know, it's a bit of an eye-opening experience to see how government really works.
And I'm sure there's a ton of moving parts, and you've got people coming from, you know, we have all these different assessment groups that want their things, and we all have to argue for what we want. I'm sure there's a lot of wrangling that has to be done.
But, you know, doing that kind of thing opens up all sorts of doors too, because then, you know, I can pick up the phone and talk to the associate administrator for the Science Mission Directorate. I can talk to the NASA administrator, you know, Jim Bridenstine, who was administrator until recently, and talk about issues that are arising. They ask for some occasional help. I, you know, talk with them about things that are moving along, and not being part of NASA, I have the ability to also do some lobbying up on Capitol Hill and go to advocate for things having to do with NASA, like, you know, behind me, you know, the lunar program and returning both astronauts, as well as putting low frequency radio telescopes on the far side of the moon.
So with this onslaught of new experiences and you know, things that you're learning and people that you're talking with, was there anything that surprised you about working on policy with high-level government officials?
Yes and no. You know, I think what you find is, especially at NASA works, you have people that they're always bringing in scientists like myself, and you know, throwing them into the deep end of the pool, if you will, and getting them familiar with programs and having them administer grants programs or mission programs. So you see a number of folks that are in that process learning. But I think one thing maybe surprising, everybody is mystified about how the government really works, you know, or how it doesn't work and how things happen. And the thing that, you know, we don't often appreciate in the university environment, where, you know, we're very focused on peer review, as we should be, and writing good proposals and making sure that they hold up to peer review. A lot of what happens on the larger programs is through networking, is through ideas. Like, you know, we've been going back and forth for the last 20 years. Do we go to the moon? Do we go to Mars? Do we go to moon? Do we go get an asteroid? Do we, you know, all sorts of changes like this. And those generally happen at the whims at the highest level. Sometimes, you know, right in the Oval Office of the president decides, you know, I kind of like the moon, or you know, moon's old hat, been there, done that. Let's just go to Mars, you know, and that's been very unstable for NASA and the space program over the last 20 years. So I think we're starting now. One of the things both we did 4 years ago and the transition team for the incoming Biden-Harris administration, just finished up, was let's not do that anymore. Let's not blow everything up every time a new administration comes in, but rather let's build on what we have. Of course, we put our signature programs in. You know, the Biden administration is talking about more emphasis on global climate change and earth science, but also, you know, keeping the forward momentum with respect to the moon. So, you know, it's interesting. I think this is what's eye-opening to a lot of us as scientists. It's not always peer review. Sometimes these things are just raw politics.
On the converse side, I've heard anecdotally that a lot of times the politicians really have no idea how science works. Do you have to do a lot of educating from the science side to the politics side as well?
It is, yes, Tara. That's a really good question because I think there's a lot of misunderstanding in the Congress on how science works because, you know, the vast majority of legislators are lawyers. And there's very few that have any science background whatsoever. And so part of the difference in how science works is, you know, we're very careful in how we present, you know, our conclusions. And rarely do we say, this is the final answer. There's always more work to be done. There's always more analysis. There's always more data to be gathered. So it complicates things for members of Congress who are looking for a clear-cut answer. So I've had the opportunity to testify to a number of committees on Capitol Hill over the years, and more often than not, they'll say, you know, Dr. Burns, if we give you $500 million, can you, or $2 billion, can you solve global climate change? You know, wow, you know, that's a stunning question. Or, you know, can you build a telescope to detect life elsewhere in the universe and to determine whether or not a particular exoplanet has life? I mean, things like that. And of course, we then start saying, well, there's, you know, lots of qualifiers associated with this, and, you know, we can look at this aspect of global climate change or this aspect of habitability for other planets. And unfortunately, the interpretation of that by at least some of the Congress is, well, you're not really sure, are you? You know, you don't really know exactly what this is. So I'm going to take that answer as a no. And of course, that's not what we're trying to say. What we're trying to do is be careful. We're trying to say there is more work to be done, but there are certain aspects of these problems we do understand and that we can make some comments on. But, you know, it's not black and white. Politics is often black and white, especially today. And instead, science is very much made of grays.
Do you find that when having these kinds of conversations and you and fellow scientists that are talking to politicians, is there any sort of kind of unspoken rule that you should just say, give a black or white answer and say, yes, I can, in order to receive funding that you've asked for, rather than being honest and say, well, you know, we have to do this and check this and do this, and then the interpretation is, so no, you can't, so you don't get the money?
Yeah, no, I wouldn't recommend that. And I think our job really is also to try to educate members of Congress on actually how science works and to give honest answers, but also be clear. Don't get so wrapped up in the details, because we as scientists often, we go right into the weeds right away, you know, because we love details. That's what, you know, we're good at, and we publish our papers in the Astrophysical journal that are meant to be very detailed. And but when you're talking to politicians, you need to keep it at a higher level that is understandable. Use analogies as much as possible of everyday experiences. So it takes some time and takes some experience to learn how to talk to people in the Congress. On the other hand, it's really not much different than you talking to your neighbors or roommates who may not be in the sciences, and learn to present to them. That's a good way of how you practice to do it. At the AAS, the American Astronomical Society, what we've been trying to do for years now, and part of what I did when I was on the committee for public policy, astronomy and public policy, is to bring young people into Washington. We have every March, when COVID is not on, at least every March we have a day or two in which we bring folks in. We usually spend some time trying to talk with them a little bit first about how the Congress works and how to approach it. And then you just go right in. So usually with a senior astronomer and folks who are students, undergraduate, graduate students, postdocs, and bring them in and meet with members or their staff. And learn how to talk to them, learn how to make an argument like this. So again, try to nuance things with grays when it's appropriate, but also get, you know, a clear enough argument so that the funding we need this year to finish and launch the James Webb Space Telescope, this is why we need to do it.
I'm wondering about this. You mentioned having to deal with transitions between administrations. And of course, this happens every 4 or 8 years. But a lot of these missions that we work on can last for decades. I know, like, I work on Europa Clipper, and it was approved in like 2004, and it's still not launching for another 5 years. So how do you communicate this timeline that may be, you know, 3 or 4 administrations ahead of the one you're working with now?
Yeah, I mean, and the Europa Clipper is a really good one, because Europa Clipper, without a congressman, now retired congressman, or actually a congressman didn't get reelected from Texas, Culberson, you know, we really wouldn't have the funding for the Europa Clipper right now. You know, Europa Clipper was one of the things that was listed in the last Planetary Sciences Decadal, but it wasn't at the top. Culberson took that and said, hey, I'm really excited by Europa. There could be life. There could be whales, you know, in the ocean, Europa. And, you know, let's really put some money into it. So that shows you the example. And this particular congressman was not from a district that had any NASA facilities. He's just interested. You know, he was just interested in. So he used his position as, at that time, chair of the Appropriations Committee that oversaw NASA in the House to be able to put some initial funding in and to make this go. So having, you know, allies like that, along with an endorsement from the community through the decadal survey, you know, that combination makes it go. But you're absolutely right, Tara, that this is tough when you have missions that go on. Again, James Webb Space Telescope is going on 20 years now in terms of when it had its first recommendation. We're still waiting for it to be launched, hopefully later this year. And so what we find, and one of the things that's frustrating for scientists, is every 4 years, even every 2 years, you have to go in and make the case all over again for a new group of people that are coming in and try to get them excited about it. So it's never, and just when you think you've made the case, everybody's solid on board, appropriations last year look really good, and if you let go and don't do anything more, that whole thing can collapse. You got to be right back in there and making the case every year.
So shifting gears a little bit, we also wanted to ask you about this sort of new development of the commercial space industry and kind of how that affects policy decisions and things like that. Have there been policies put in place already to kind of bring the commercial space industry into the fold, I guess? And how difficult is it to regulate those? Do you do it in the same way that you would through, for instance, NASA or another government agency?
Yeah, I mean, Tara, this is a game changer for space. Having public-private partnerships. This started going back all the way to actually the George W. Bush administration, when he decided to close down the shuttle because it wasn't really safe any longer, and go with a different model. And that model, which we're just now seeing coming to fruition, is with SpaceX and Boeing creating the commercial crew program. And we've seen for almost a decade now the commercial resupply program. So the idea there, which is a break from the tradition that NASA had, is that NASA would procure rockets and space vehicles, capsules, shuttle, and then they would operate, have their astronauts on board, take full responsibility for it. The new idea that started with the Bush administration continued through Obama, and the nice thing about this has been very bipartisan, and then also continued through the Trump administration, was the idea that NASA, instead of owning and operating all of these things, would buy services. Because the private sector, unlike 50 plus years ago when we were doing Apollo, only the government could do all of these things. But now the private sector is more than capable of building, and have demonstrated they can build the rockets, they can build these space vehicles that carry astronauts and resupply, and they're more than capable also of building a next generation space station in Earth orbit. And so that then in principle frees up NASA to do only the things that NASA can do. And that is the moon, and even more so Mars, because Mars is really, really hard, really far away, really requires vehicles, in spite of what Elon Musk says, really requires vehicles that only a large government program can still do. So that is extended now to the moon. So vehicles like the one you see behind me is part of the new commercial human lander services contract that NASA's put out. It's put out to a contract to 3 companies: Dynetics out of Huntsville, Alabama, Lockheed Martin and Blue Origin in Seattle, Lockheed here in Colorado, and the third one is SpaceX, and all to design a next generation human landing system that will bring astronauts to the moon, as the now former vice president said, bring the first woman and next man to the moon later this decade, hopefully mid-decade or so. And the same idea. So NASA buys services. So NASA buys seats. They buy seats for the commercial crew program to go to the International Space Station, and we're going to buy seats on these landers so that the companies that build these, then they do the design. They must also insure these. They are the ones that launch. NASA, of course, is overseeing a lot of the safety issues to make sure that these things are safe. But in principle, these will reduce the costs to NASA to be able to do some of these things in space, and at the same time, get the space economy going.
So you mentioned them buying seats. So this isn't exactly like a, purchasing, like going to Target and buying a pack of coffee or something. This is a little bit different than just a pure buyer-seller relationship.
$50 million per seat to go on the SpaceX to the space station. But that's less than the $80 million that the Russians were charging us to get our own astronauts to the International Space Station. But you're right. But what's interesting is there are lots of rich folks out there. SpaceX announced recently they're flying an entire crew, 4 people, to the space station that are buying their own seats, and NASA has no involvement. This is the other thing about the things like commercial crew, is that not all of the missions are driven by NASA. So that companies like SpaceX will be bringing astronauts from ESA, from Japan, and from the private sector to go up into space. They can make money that way. They can sell seats to billionaires. They can sell seats to ESA, JAXA, any of the international communities. And there's a business plan. There's money to be made from that, and NASA is encouraging it. But you're right. Certainly not. Those of us who of normal means cannot afford to just go out and buy a seat on one of these vehicles.
So I think this kind of opens the door to a discussion about how are we, being the United States or any country, regulating, commercial spaceflight, right? And I think maybe a good place to start would be to talk about the Outer Space Treaty of 1967, which so far I believe has been ratified by 110 countries. Can you give us a quick overview of the OST?
Yeah, the Outer Space Treaty really was it was an amazing document. It was signed by President Johnson in 1967, so in the middle of the Cold War. Had the old Soviet Union, the Chinese, and it was groundbreaking in that, what it declared was that, the exploration of space is supposed to be for peaceful purposes. There are not to be any nuclear weapons placed in space. And amazingly, over the last 50 plus years, that is been maintained as far as we know. That exploration, that bodies like the moon are open for everyone. No one owns the moon, no one owns Mars, no one owns asteroids. But at the same time, everyone can go there, can explore, and presumably can extract resources as well from those bodies. So it laid the foundation, the beginning foundation for what is the international laws or rules, if you will. Now, what's interesting is that's the last major treaty that has been signed by a large number of countries, and that goes back to 1967 for as far as space is concerned. One could argue we haven't really needed it anything more up until now, but today, with again things like what's going on here behind me with the commercial sector going to the moon, with individual countries and companies going to the moon. How do we do things, for example, like protect the Apollo sites? The last thing you want is some company going to the moon, landing by the Apollo 11 area, and going in and carving out Neil Armstrong's first footprint, bringing it back to Earth and selling it on eBay. That's not good. That's not. So how do we begin regulating, these kind of things? So really where we are right now is it's really the Wild West, that it's a frontier. We are well behind in the development of space law and international space policy for regulations like this. Now, NASA under Administrator Bridenstine tried to take a step forward with this in recent months with the so-called Artemis Accords that invited other countries to take the Outer Space Treaty a little bit further, recognizing that in the next few years we are going to be making regular trips to the moon and then other bodies. And how do we deal with that? How do we, one of the issues that keeps coming up over and over again is extracting resources from the moon, water in particular, which can then be turned into rocket fuel, hydrogen and oxygen, and other materials. There's a lot of precious metals and ordinary metals, aluminum, magnesium, that can be mined from the moon and potentially used. So how do we do those regulations? So we really need to step up. Not only do we need to step up in terms of exploring and getting astronauts out there and getting our science missions, on the moon and beyond, but we need to step up on space law.
And the Artemis Accords, they seem like they're moving in that direction, at least trying to get us protection for these historic sites and stuff, mining and things like you mentioned. But it seems like there's been some challenges getting other countries on board, especially all of the other spacefaring nations, to get them on board with these Artemis Accords. Is that something that's due to, you think, the accords themselves, or is there some bigger issue with getting this international cooperation?
Yeah, that's another good question, Tara. It's a little hard to tell. It might partially be because this was issued during the Trump administration, which of course very controversial, so much going on associated with it. And also that the US was putting this out, because the US has already declared with Artemis, it's going to the moon, going to do new missions, and going to encourage mining. And so some people, I think, misunderstood the Artemis Accords, saying, oh, well, the US is basically going to, you know, make claims on the moon or asteroids or other things. And that's, if you read the Artemis Accords, that's not what they say. What they say is just trying to extend and to modernize the Outer Space Treaty from 1967, taking into account all of these commercial opportunities, which in 1967 we never would have, you know, guessed would be the case, because it was all government programs, you know, in those days, and really just the old Soviet Union and the US. So I think there's work to be done on those accords, and I hope that the Biden administration picks this up and, you know, continues along this line, because to me, at least, the Artemis Accords looks like a good starting point, but only a starting point of a new generation of space policies and international agreements. We do need some international agreements. So, you know, another area that I spend some time working on is how do we keep the far side of the moon quiet? Okay, so we want to explore the early universe, the dark ages and the cosmic dawn, using highly redshifted neutral hydrogen at frequencies from about 10 to 100 megahertz. And the far side of the moon right now is ideal, because we get away from radio frequency interference from the Earth. There's no ionosphere, all of which interferes on the Earth. But with some of the developments of the moon and infrastructure that begins to development, we could begin making that environment noisy again. And so we do need international regulations. I mean, if it's just the US, you know, we can certainly control the outputs using electromagnetic compatibility plans and, you know, some shielding. But what about the Chinese? We don't even talk to the Chinese. You know, I mean, by US law through the Congress, you know, we're not allowed, me as an investigator, I'm not allowed to spend any of my NASA money on any work with the Chinese. That's crazy. That's really dumb, but that's the way it is. The Russians aren't particularly friendly these days, so, you know, they off doing their thing. But even countries that are more friendly to us, look at the, you know, the Israelis launched, it was a combination government program and private sector, a first attempt to do a soft landing on the moon with a small payload. And it turns out that they carried on board, not known to anybody at the time, these tardigrades, you know, and these tardigrades, these tiny little creatures, they're really robust. They're able to survive sometime in a vacuum. They're found everywhere on the Earth in really exotic places. And they brought these to the moon. And then they crashed, and these tardigrades just sort of plopped, we think just plopped over on the moon. Now, they probably lasted maybe, you know, a few hours or a few days, and that was the end of them. But still, wow. I mean, what kind of, you know, what international regulations should we have about, you know, preserving these territories? I mean, if it were Mars, that would be much more serious because, you know, they could survive on Mars. They could be mistaken for life that developed on Mars. So there's an example of which, you know, you would have thought both the country and the companies involved should have been more responsible. But somebody got the wild ideas, hey, let's bring these along and see, you know, how well they survive. It's like, okay. So we need to do, we need to be thinking about these things more.
It seems like there might be a few of those sort of rookie mistakes coming up with all of these brand new space programs coming up and with a lack of regulation. Is there any other space program, ESA or JAXA or anything that's putting forth any regulation for the international community? Or is Artemis kind of the only thing that has been put out?
Not much, you know. So I think what Jim Bridenstine was trying to do, he's just trying to put a marker out there. He's just saying, all right, you know, we're all moving in this direction. So in addition to the new generation of rockets and space vehicles and, you know, manufacturing and mineral extraction we like to do, how about we also make some progress at the same time in the policy arena? So he sort of put that out there as a challenge. Not many others have picked that up yet.
So I'm curious, and this is kind of, I think, a question on policy as a whole, space or not, but specific to space policy, how do you convince other nations to go along with an agreement, right? Obviously, the nation that drafts it, if there is one, you know, is probably going to put things in that it prioritizes. Like in the U.S., right? It seems to be, hey, we don't want to wreck historic sites, and like you said, maybe we would love if the far side of the moon could remain quiet. And then some other nation says, well, yeah, but we don't want that. So how do you get nations to work together to sign a document that they all follow the rules of?
Yeah, Colin, that's just a great question in general in terms of international relations. So maybe we can draw on our experience with nuclear weapon regulations, okay? And the way you approach these things is to develop agreements that is in everybody's best interest. You know, if the Russians launch nuclear weapons to the U.S. and we retaliate, nobody wins. That's the old mutual assured destruction strategy from the 1960s. And so I think people realized when the first set of these treaties were signed in the 60s, right up to the present time, that it's our mutual benefit. I think approaching these kinds of things with respect to the development of the moon, again, asteroids, Mars, where are the things where we can find some common ground, where everybody's going to benefit? So in other words, where we can open up opportunities so that everyone can take advantage of those. Everybody, wants, a little leg up because, if you're a company, you want to make a profit. If you're a country, you want prestige, associated with these advances. But within that framework, can you do that if everyone has an equal opportunity? So I would approach these negotiations is, where do we find that common ground? Where do we find things that is going to be to everybody's best interest to do?
So we talked about how there is kind of a lack of space policy right now, especially considering where we are technology and science-wise. And we've talked about the Outer Space Treaty and the Artemis Accords, which both seem somewhat limited in scope, right? With the OST being kind of focused on nations and weapons, and then Artemis being focused on, close nearby terrestrial bodies like, the moon, Mars, comets, and asteroids. So I'm curious, in your opinion, should we begin to look at, bodies further out, right, and try to develop policy that might cover those sorts of things? Or is that something that we should cross the bridge when we get there and right now focus on?
Yeah, Colin, that's an interesting point. And I think I would take the approach of let's step to this, a bit at a time. So let's focus on the immediate needs, because these things that are more, distant or in the future, politicians tend not to pay much attention to for some of the reasons we were talking about earlier. They're really focused on what's going to happen in the next few years. So I think many of the policies that we put together for the moon would end up being applicable to mining asteroids or what we'll eventually do on Mars. So let's start there. And I think we need institutions who, like the University of Colorado, who are prominent in the space sciences to be involved in this. So my colleague Dan Baker who's the director of LASP. Tara, I'm sure you know. Dan also teaches the space policy class. In fact, he's teaching it this semester. And so we've talked a number of times to the CU administration as well as to folks at NASA about developing a CU Science and Space Policy Center, in which this would not just be for scientists and engineers, but we bring in the business school, we bring in the law school, we bring in the social sciences and the arts into this, because it's a wide-ranging arena. And we start talking about some of these issues. So we start off, these things are academic, and then they evolve into practical suggestions that we might forward to our members of Congress, who are, they're very well aware, our senators and congressmen, of how important space and the aerospace infrastructure is in Colorado, how important that is to the economy. So these public policy issues then also feed onto that. How do we make sure that we will continue to have the broadest set of opportunities to move forward? So anyway, we've been talking about that, and we've got some, some outstanding folks on campus already in law and business and the other colleges beyond arts and sciences and engineering that could be brought to bear. So unfortunately, we got sort of held up with the whole COVID thing over the last couple of years. There's no new initiatives going forward at the moment for obvious reasons, but we would certainly like to get back to that.
That is a very cool idea. I like that a lot. In a similar kind of vein, we know that especially space science is changing all the time. There's so many new developments and technologies and discoveries. How much of the policy that we're implementing is sort of reactive to these new discoveries, and how much of it would you maybe consider proactive as far as what's coming in the future?
Yeah, I don't know if our science discoveries necessarily are causing us to be reactive as much as what they're showing to members of Congress. And the decadal surveys are really good at doing this every 10 years. We're ready for the new astrophysics one to come out any month now, next couple of months, and the Planetary behind that. It shows the potential of what we can learn in space. And the nice thing I find that as you all do is, talking to friends, neighbors, people on airplanes when we can fly on airplanes, and members of Congress, is they're fascinated by what we do. They're fascinated by the solar system. They're fascinated by black holes and neutron stars and all of the amazing technologies that are opening up these scientific frontiers. So we want to keep their interest. And so all of these discoveries, making them public, talking about them, what it does is then a member of Congress who says, you want $10 billion to build the James Webb Space Telescope? Oh yeah, but look at what we're going to do with it. Isn't it remarkable that a community as small as ours, with sort of 7,000 active astronomers and astrophysicists and planetary scientists, that we can do projects that are $10 billion of the public's money? No other science does this, not chemistry, not physics, not biology. Per capita, we have far more public money. And the reason is what we do is really cool. And we want to keep promoting that. And so in that sense, I think that we're being proactive in getting that message out. And then it allows us to come back with our decadal survey and say, hey, we gotta get those samples back from Mars. We've got to, we got to get to Europa. We do an orbiter and we find something interesting. Maybe, we get that lander going, because maybe the water worlds are really where life is, not on Mars. So, let's go figure that out. Let's get to Enceladus and, figure out what's happening there. So I would say it's we have a real advantage in our community because of fascination of the public and what we do. What we do is exotic.
I'm curious, in your experience, have you heard much criticism of funding space science, with the argument that there's a lot of stuff here on Earth that needs to be taken care of? So why do the space scientists get the most public money per capita, when other things are happening?
We're just cool. That's just what it is. It was just cool. That's all it is. I mean, these other scientists are not cool like we are. And lawyers, they're really not cool at all. So, I mean, let's face it. So, but
for those not watching the video, Tara and I are cracking up in the background here. Way to go. That was great.
But more seriously, it is just that we do benefit from this idea that we're exploring things that make the best of humans and who we are, that we're exploring from it. We've always been explorers, whether you're talking about going to new continents, whether you're talking about going to new bodies, or exploring the cosmos. And what is that frontier of exploration? It's space. And being able to write it makes people's everyday lives and the things that we face with day to day, look like, okay, this is sort of why we're doing it, so that we can expand our minds and understand, what else is out there. So, it really is pretty remarkable that the one thing I do find when I do go to Capitol Hill and talk to folks, that there's a lot of nuts and bolts about, how much we should spend on particular programs, but less talk today than there was in the 1960s. It was much more in the 1960s when we were doing Apollo program. There was a lot of criticism of, should we be going to the moon, or, we've got this war in Vietnam that is raging and tearing the country apart. There is a war on poverty that is not being won. There's a social and racial strife that's going on. And so there was a real discussion about doing that. And also the cost of Apollo was very expensive, because it was really, it was 5% of the total budget, whereas NASA's program today is only 0.4% of the total budget. So what I like to say when I get a question like that is, with the wealth of this country, we can do both. We should be working on these social programs. We should be working towards more equality and opportunity in the space programs and everything that we do. We should be working on bringing up individuals' economic status, and we can still, do these missions to the moon and Mars. We can afford to do both, and we should be doing both.
I'm going to say that number one more time, because this is an argument I hear a lot of people say, well, we're giving you tens of billions of dollars. It's 0.4% of the budget. So really
it still is tens of billions of dollars. It's $23.5 billion is NASA's budget for this year. So it's still a lot of money, but compared to the entire federal budget, the roughly $4.5 trillion budget, it's a small fraction. I mean, isn't it amazing how much we get done with that amount of money?
Absolutely. Excellent. So we're going to move on now to what we call our Capcom Q&A. This is where we have questions submitted by our listeners to pass on to our experts here. So we'll have a couple of curveballs to throw at you, if that's okay.
Okay, that's fun.
Excellent. So our first question here comes from Charlotte in Austin, who wants to know what policies are in place space trash and pollution.
Yeah, that's also an increasingly important problem, because more and more we find that low Earth orbit in particular is filled with a lot of debris, and it's dangerous. There's regular punctures to the International Space Station. Fortunately, no one's been killed yet with some of this debris, but it does do damage. About 7 or 8 years ago, the Chinese blew up one of their own satellites because they were testing a kinetic weapon, not a nuclear weapon, but a kinetic weapon, blew up one of their own satellites, and it just flooded for years the environment. And so we need to do two things. One is more getting back to regulations. We need to do a better job on regulating. So in other words, you need to be a good Girl Scout, and you need to clean up and leave the campsite in better shape than when you found it, right? Need to do that. And secondly is the continued development of technologies that will collect some of these materials and then just simply toss them into the atmosphere where they'll burn up. And there's some interesting technologies that are beginning to be developed there. But this is reaching a stage where it's starting to be critical.
Next up, Ray from Georgetown is asking regarding Space Force, what is its primary objective and how do they recruit personnel?
Yeah, so the Space Force, you know, primarily I think what they were created to do, and despite the fact that this ended up coming out of the Trump administration, or something that was actually very bipartisan, that had been suggested for years, 20 years, by members of Congress, that you know, we are vulnerable to a number of new technologies that are in space. We hear about these hypersonic weapons, for example, that Russia and China are developing. How do we detect them? How do we protect ourselves? So really what the Space Force is, it's not about, you know, Luke Skywalker getting into his spacecraft and you know, fighting with the enemy, but rather it's about developing technologies, cyber technologies, new remote sensing technologies to really be better prepared for protecting the US. So it really is, the Space Force really is a technology agency that's associated with space. I don't see them launching a lot of astronauts. Will there be a Space Force base on the moon someday? Yeah, probably, but not anytime soon.
Our next question comes from Mick here in Boulder, who wants to know, what happens when someone violates space policy? Are there space police that come for you?
No, but international pressure, you know, for example, the big violation we'd all be concerned about is if we found that someone had actually launched a spacecraft that has a nuclear weapon, you know, on it. So it's poised in low Earth orbit. The international outcry would be enormous, and the pressure to remove that is what you would count on. But there is no space police. You know, that's not what the Space Force is going to be doing with the last question. But public pressure, international pressure, is what we would continue to rely on to, you know, to be good citizens, good international players.
And a question from me, just because you mentioned that, do they regulate spacecraft using that are using nuclear propulsion in the same way that they do with nuclear weapons? Is that something that the international community is involved in, or?
Not at this stage, because the technology is not far enough along. So, you know, people have been working since the 1960s on nuclear propulsion systems, nuclear electric propulsion systems. So small nuclear fission generators that would produce basically an ion beam that you would accelerate a spacecraft. But the amount of nuclear material that you're talking about is still relatively small, and also likely would not be weapons grade. So wouldn't, you know, wouldn't be as much worry there for getting in the wrong hands, although it's still some amount of worry. You still would worry about it if it exploded, and then, you know, some amount of plutonium or other radioactive material, although even there, it diffuses to the atmosphere very quickly. So, but Yeah, that's an area, it's a good question. That's an area where further international regulations, I think, could have some good effect, or good laws or good treaties to deal with that, because clearly we're going to be moving in that direction in the next 10 years. Because the current propulsion systems are just not, not good enough. I mean, my goodness gracious, it takes 8 months, 9 months to get to Mars. That's not good. That's not good enough. I mean, we need to cut that in half or cut it in a quarter, and using, starting with solar electric propulsion, then nuclear electric propulsion systems is clearly where we want to go. And then furthermore, on the moon, we want to have some small nuclear reactors to generate, gigawatts of power, so that people can do mining, manufacturing, and to support colonies that may be there on the moon.
Cool. So in regard to that question, John actually just typed a question into our Capcom document here. And John wants to know, do we have a vehicle capable of deorbiting a nuclear weapon, or would it need to be dismantled in space if someone were to send one up?
Yeah, good question. I'm not familiar enough to, I think, to probably offer a good answer to that. I would worry about deorbiting a nuclear weapon and have it break up in space, and again, the plutonium material be distributed. So, I would think that you would want to bring it back, or alternatively, put a propulsion system on board and shoot it towards the sun.
That seems like a safe way to dispose of your dangerous spacecraft, is just to send it into a star.
Yeah,
It's not going to do any damage to
the sun wouldn't mind.
Yep.
It would love to eat our nuclear weapons. So
hey, thanks for the fuel. I appreciate that. Yep. So our last question comes from my roommate, actually, Mac, who is initially from Boston, and
Boston. Yeah, gotta get some lab stuff from Boston.
Yeah, there you go. So Mac is asking, what major changes in space policy do you see with the Biden administration, particularly with regard to commercialization?
Yeah, unfortunately, it's too early to tell. The Biden administration had very little to say about space before they came in. Again, because of the unusual campaign, most campaigns would put out a white paper on space in advance. And this time that didn't happen, because of course we knew what the Trump administration is. So at this point, that's really, the Biden administration is a bit of a blank page when it comes to space policies. But given the support of the Obama administration for commercialization of space, I expect that will continue. And I think there will be a number of supporters who will be coming to the White House who will be arguing that, including a number of those billionaires like Jeff Bezos and Elon Musk and others who have the resources and maybe campaign donations to support this this kind of thing. So I expect they will be pretty positively inclined. Maybe again, looking a little bit more at regulations and beginning to think about sort of narrowing down this Wild West mentality that's out there a little bit. But I think that's to be determined. Some of this might be led by the new NASA administrator. We're hoping that we're going to see the first woman named as a NASA administrator. That's very much in the mix at this stage. Some very, very good, capable folks who've been, their names have been circulated. But also the other place where policy is made is the National Space Council. And that was actually very effective. During the Trump administration, they reconstituted the Space Council, and the Space Council deals with space issues across the government, not just NASA, but the Department of Defense, Department of Energy, NIST, and so it's a good coordinating body. So there's, the kind of thing too, that if they decide to keep that, where you might expect some space policy to emerge. But I would say, wait a year. It's probably going to take that long before we'll start seeing some real space policy being made out of the Biden administration.
So we'll have to have you back on the podcast a year from now and ask you again.
Love to do it.
Excellent. Well, it looks like that is about all of our time. So thank you again so much for joining us, Dr. Burns. This was a fabulous conversation. I feel like I have 17 more questions, so we'll definitely have to have you back at some point.
We'll pick those up at another time, but it was a pleasure to be with you all.
Thank you so much. All right, everyone, that is all of our time for today. We want to thank Dr. Jack Burns again for joining us. That was an awesome conversation. Super cool to talk to him. Don't come back next week. Normally we would ask you to listen next week, but this is our season finale, so there will be no new episodes of A View from Earth next week. But hopefully we'll be back for another season coming up, maybe in the summer, maybe in the fall. We do want you to check out our website to keep an eye on that. And as soon as we know more about our upcoming episodes and seasons, we will be posting those online. You can also go online to look at any of our past episodes. You can access those from there. For the future, there is an option to leave us questions for the Capcom Q&A on the website as well. Just keep that in mind for down the road, You can also subscribe to the podcast so you'll get automatic notifications when our new episodes publish. You can also use that link to help donate to the podcast in case you want to help us keep going into the future. We would love support from viewers like you. In the meantime, you can find us here on YouTube, SoundCloud, Spotify, or Apple Podcasts. And a big, big thank you to all of you for listening to us for all of these semesters. We really appreciate it. And we hope to see you again soon.